Okay, back in business. What is a polyhedron? Is a solid with all flat surfaces that encases a single region of space. So the region of space that it encases was the volume that we were covering before density. Volume and density deal with the space inside. Today we're talking about the surface area, but there's some review in the beginning of different terms that we've talked about. The line segments where the faces meet, so like here where the faces meet, are called an edge. The points where three or more faces meet, so these points here, are called a vertex. A polyhedron is considered regular if the faces are congruent. That's a term we used back in the polygon topic because there's regular polygons if all the sides are congruent. A polyhedron is a regular polyhedron if all the faces are congruent, all have the same area. The common polyhedron are prisms and pyramids, which we've been discussing in terms of volume and density. What is a prism? A prism is a 3D figure with two parallel congruent bases. Now, a rectangular prism, like this first picture, has all the opposite bases congruent and parallel. But that's unique for a rectangular prism or a cube, which is a rectangular prism also. Like the blue faces are congruent and parallel, but then you have like this front face that's congruent and parallel to the back and the other sides as well. So no matter which way the rectangular prism's sitting, you always have congruent opposite parallel bases. With the triangular prism or any other prism, that's not the case. The only congruent parallel bases are the triangles. The lateral faces, which is the language we've used already, this topic, the rectangles are not parallel and they're not necessarily congruent either. So now we could discuss what the shapes and the faces, how many faces there are in each of these solids, because when you're getting the surface area, you're getting the total area of all of them. So for a rectangular prism, there are 6 rectangular faces, but there are 3 that are the same. So like here, this top and bottom are congruent. Then you have the sides. Trying to see. I might have just messed that up. This one would be opposite when you fold it to the other rib. This one here will be parallel and congruent to that one. And finally, these two. So when you get the surface area of a rectangular prism, you really only need to get the area of 1, 2, 3 of those rectangles, and each of them you multiply by 2 before adding them up. A triangular prism has 2 triangle faces that are the same. So you only have to get the area of one of them and times them by 2. And then you have 3 rectangle faces, though they're all different. 1, 2, and 3 could all have different lengths. If the 3 lengths of the sides of the triangle are different, these 3 lengths are going to be different. However, all of the dimensions across here are going to be the same. That's going to be the height of the prism. So they'll all have the same, one dimension the same always. And then the second dimension can be the same if the triangle is isosceles or equilateral. But if they're scalene triangle bases here and here, then all of them will have different widths. And finally, the cube, which just doesn't look like a cube, has 6 square congruent bases. So you just have to get the area of one of those squares, and then you could times it by 6. Um, all right.